So far you have done some computation using Python, but you have not read some data or written some data using Python. So if you are doing some simulation, or if you solve an ordinary differential equation and if it takes a longer time, then you won't be able to analyze that on the fly. So what you need to write those data in some format, and then at later time you can analyze those data. So I will discuss these things today. So there is one format called ASCII format, which is the American Standard Code for Information Interchange. So you can use a text file to write data, and that is so this is ASCII. There are different format of ASCII. So text file is one of them. So I will discuss about this. So for that you need to create an object f, and this is a function file. So you write you keep a name of data.txt. So data will be saved in this file, and W stands for writing. So in next line is f.write, and I have written this is my data. So you can write this string will be written in that txt file, and next is to just say f.close. So this is the simplest example to write something, whatever you want, right? Now if you want to write some array, so how you will do that? And please stop me if you have any problem in understanding. So for that I have x is linspace. So everyone knows linspace. So it goes from -0.9 to 0.9 with 100 data sets, and y is some complicated function. So this it's a simple function, but it could be a very complicated. You can solve an ordinary differential equation and you get some y. Then again I have created an object f, and here is the data.txt, and I have written this is my data. So hash is the comment. So if you write something in Python with hash, that is taken as a comment, Python will ignore that, and /n for the change of line. So when you get those data, you can write some comment about that data. Then I have run a loop for I in range len x. Len x is the length of your x array, and write %f. %f is the value of that data, and for xi, then /t is the tab, then again %f for this yi, and then /n the change in line. So how loop will work? So for x is equal to 0, so it will write the x0 value, then a tab, then y0 value, then change of line, then again the loop will be using, and you will get all set of it. I will demonstrate this. And next is to close that file, and if you want to read that data, then you just have some name. I have put data np load txt and data.txt. So it will take whole 2D array, and now you can so if you have x and y and some data, so it will, so these two vectors will be inside one array. So now you can use x colon 0. So it will take this x data, and next will be, so 1 will take y data. So I will demonstrate this. It is visible or not? So space 0.9, its y is x6 minus x4 plus 0.2 x square. So if I want to plot this, so you have x comma y. So now I will write this data and read it, and will test that is whatever I have read is exactly gives this function or not. So I have created object f. So I can write some comment. So now it has written the x and y values. So if I want to read this, so data.txt has, this is my data and then x values and y values. Now I want to load this. So let's call data to load. And if I want to read what is x, so colon 0, so it will give the x values. So from 0.92 minus 0.92 point. Let's plot this. So this is x and this is y, and let's plot it with RP, so that will be, so it retrieves the same data. Okay, RP is, so R stands for red and P is the point. So my first curve was the blue curve, original curve, and then if I would have put R, then you won't be able to see any difference, so it would overlap. So next is about binary file. So another format is to write in binary file. So in binary it dumps the whole data in ones and zeros. So computers understand the binary system. So it writes everything in ones and zeros. So it gives the full information of the data. So I will give you an example to show how it gives the full information. So how to write in binary? So there are many formats. So I will explain the .npy format, which comes from NumPy, and another is very advanced, which is SDF5 format. So I will cover these two. So first let's look at npy, which is very simple. So let's have a data array. So this V stack means, so if you have array X and array Y, then it will stack those vertically. So if you X comma Y comma Z, it will stack all these arrays. So it forms a 2D array from X and Y. Then save. So this is my data, so you can keep any name, comma data array. So it will save this data array, and that's it. And to load this data, you need to say data np load my data and np. So this is the extension is .npy. So just .npy, it will take the array. So it's very easy than the ASCII.txt file. So I will give you example how does it keeps the full information. So x is here. So let's delete x and y. So x is not here. Let call x is 1/3029. So x is this. So let us save this in ASCII. So delete f. So f is file. So this much is reduced, it has truncated up to 142. So it is keeping how much? And 1 is point and 0. So these are 8 characters. So size of this is 8 byte. So you can check. So you can just say ls minus lh. So size is 8 byte. And my information is, I do not have the full information. It has not returned the whole thing. So it is truncated up to this point. So if I save in binary, so np.save, if I want to read this, so I can't read. So it's question mark m question mark. So it's written in binary. I can't read it in doing cat or anything else. So I need to read in Python. So np dot load. And it returns the whole information. So where is x? So it keeping whole x. So you have nothing is lost. So if you do some simulation, say of a 1000 cube data, and you have 1000 cube differential equations. So when you read that initial condition with ASCII and binary, you will see the difference, and you know about chaos. So if the initial condition will be sensitive, then it will reflect later. So that's why for doing a bigger simulation, one should use binary file system rather than ASCII file system, where you keep the full information and nothing is lost. So is it clear up to this point? So next is SDF5. So SDF5 is a very advanced version. So let's look how to write in SDF5. So first you need to install the h5py package. So if you are using Anaconda, so you need to say conda install h5py. So it will install that package. So this file is the object of h5py. So I create write file h5py file dataset. So SDF5 keeps it's a file system. So you can save many arrays inside that. So I say write file data underscore 1. So it will create a space for one array and data array. So data array was that stack x and y. I could have also done data underscore 2, data underscore 3, and as many as I want. Then write file dot close. So it will just write that data. So this is how I write the data. Now to read, so I create read file and the same data set. Then I read the data by read file slash data underscore 1. So if I have other data, then different underscore 2, 3, whatever, according to the name of that. Then I need to convert this data to numpy array, because in Python we use numpy, and then write file dot close. So it will close the SDF5 data. So we will do one example for this. So I have written one code to create data. This is a code where numpy import a library numpy, then another library h5py, and I write from 0 to 5000 with step 0.001, and y is just sin x. And again I create f for data.txt and write it in this loop which I have explained earlier. Next what I do, the same data is written in SDF5. So I stack this x and y, write them in dataset.h5, data underscore 1, this array is inserted over here, write dot close. So same data is written in ASCII as well as in SDF. So let's run this code. So we will see that is there any compression in saving ASCII and compared to SDF5. So it's done. So size of data.txt is 116 megabyte and data.set/5 is 76 megabyte. So it is reduced. And now I will load this data. So with ASCII. So we will see how much time does it take while reading ASCII data and while reading SDF5 data. So I have introduced one import timeit. So timeit is a library. So you do not need to install that. It is already installed. It comes with the package of Python. So here I have written start timer. So it will just start the clock, and here data is loaded with npload.txt, and t and x is same thing which I have described earlier, and then it is stopped. So and I will compute the time taken in this operation is by stop minus start will give me the amount of time taken in seconds. And the mean, yes, so it's done. So it's take 39.27 seconds. And I will now load with SDF5. So this is the code for SDF5. So I introduce one more library h5py. Again start, then read file, this data set, data underscore 1, convert this data to numpy array, then t, x, and stop. and it will print. So it will read the same data, ASCII which take 39.2 seconds. So any guess how much time it will take with SDF5? Huh? Half. So 0.12 seconds. So when you will do some projects in this course later time, try to save in SDF5. So that will save your time. Don't save in ASCII and then read with ASCII. So that won't be so beneficial. So while doing your project, you will save some big data. So you will get about say 200 MB or something. Then save it in SDF5. Do not use ASCII for saving bigger data. Now I will do a little bit of visualization. So when you have written those data, then you will analyze them, and so for analyzing you can use Mayavi. So Mayavi can create some density plot and isocontours. So this was made by the Indian person, IIT Bombay, Prabhu Ramachandran. He is the creator of this Mayavi package. So this is one of my research problems. So I will just demonstrate this. So how to create. So this is the hot fluid which is trying to go up, and the cold fluid which is trying to come down. These are the plumes. So if you have this data and if you want to create, here I have the isocontours and also the density plot. So how to use, what you will do, it is something similar to what you use in matplotlib. So you just say maya.figure, this is the background color, and then size 800 in 600 pixels, and I have an array T, so that is temperature. So you could have different array according to your problem, and I set a color map, say jet. So there are different color maps, so you will be able to see later. This is for the contour 3D. Now if I want to plot the density plot, so I source this scalar field T and I write this surface SRC, color map spectral, and opacity is 0.7. So what does opacity is move from 0 to 1. So if you decrease the opacity, you can see inside the structure, and then you set the color bar. So this is similar thing you have already done with your contour plots of matplotlib. So and this is orientation, so you can change your orientation and number of levels. So I keep 3, and then maya.show, so it's similar to plt dot. So I have a data.tfr.h5 which is of 128 MB, and let's do this. I should show you the code. So forget about this. So you should just take this Mayavi package. So you need to install Mayavi also. So you need to say conda install Mayavi, then you will be able to import Mayavi library, and just ignore this much. So I take theta and I convert theta to t, and this is same what I have shown in the slides. So let's run this code. So now you can visualize this. You can go inside and see how the structures are formed. So when you take your project, you may need to do not similar kind of problem, but something close to that, and you can produce some very nice plots, and that will be very useful in presentation. The colorful plots are always useful. So this is what I wanted to show regarding today's class. So I have some other. So if you want to use, okay, color map. So yeah. So you have different color maps. So I have put jet, you can put these many color maps. So with different color maps, you can just keep on trying and get the best you can get. So I have just copied few examples from Mayavi site. So just I will demonstrate this. So then, like spherical harmonics. So you can just see this orbital. So I think last quiz there was problem with something like, so you can make as many as, and you can just play with these things. So it has done all the spherical harmonics. So if you look at the code, I will give you these codes. So it varies n from 1 to 6 with m with range n, and it will just take the spherical harmonics from SciPy package. So don't worry about this code. So, and another example of the magnetic field lines. So this is the magnetic field lines from a magnetic dipole. So, you can try this. At this link you will get the information about, if you want to know more about NumPy array, Numpy shape, so that NPY file system, you can use this link. The other link is for H5PY, and this is for the Mayavi example gallery what I have shown just now.